So hello everybody, thank you for coming today sharing our talk on SDN. My name is Dionis Christoph, I am a senior wireless architect for the IdentiFi platform. And I just wanted to stop on this slide because we started to discuss about the things without putting the whole picture in perspective, which is basically what's the benefit of SDN, why we are talking today of SDN and why we put effort in SDN, because it's a network-wide objective. It's not about the openness. It's part of it, but it's because you can achieve network-wide objective. Without achieving network-wide objective, you cannot provide modern network. That's the key of SDN. How this achieved? The technologies which helped achieve that. And technologies are basically separation of control and data plane. Traditional networking and traditional network have bundled together data, control, and management. And they have just partial view of the network, which they can derive from the surrounding elements. They don't have a network view, and they can achieve network-wide functions. The programmable data plane, function of the data plane is not hard-coded, has to change based on the need of the network, what should be forwarded, what should not be forwarded, and different policies, behavior that has to be enforced. The technologies which help achieve the network objective. Virtualization network is basically looking in the same common physical network in a different logical view, slicing the network. Key for be able to deliver evolution of the infrastructure separately of the services, which are key to providing automation and orchestration on top of the solution. So these all things, automation, orchestration, innovation, depends on these technologies to be built into a system to achieve the normal interfaces where maybe we'll achieve standardization. That's where your product is. In all these other levels, from network element, southbound interfaces, controller, in order to come to the northbound interfaces, we can provide services across the whole network. And this is where you sell your product. This is where you define your product. This is where you become better than the others, if you do the job better than the others. The northbound interface is the one which we have to standardize, the one which we have to make open, and we have to be available to everybody. And probably you write in a Python, if that becomes to be a Python implementation in the open daylight. So, saying all that, this is our definition of the software-defined network. This is what is software-defined network. It's not just OpenFlow. OpenFlow is actually the southbound interface, and one of the possible southbound interfaces on this architecture, live between the controller and a network element. It can be proprietary or can be something else. Can be forces. The standard that was in the last decade tried to do the same with OpenFlow and is doing failed because it was not pragmatic. It required network structure replacement, reprogramming to implement the standard, while OpenFlow was successful because it was pragmatic, saying we are going to do what you can do and we'll extend on top of that. The IdentiFi SDN architecture is follow the time of evolution of SDN without being directly related to any of these processes. For example, the pillar of SDNs like active networks, the control data plane separation, OpenFlow or southbound interfaces, programming about southbound interfaces and network visualization, you have a long history, a lot of projects, a lot of technology were for the last, from 1995, contributed to forming of the vision what modern network should look like. And this is how the IdentiFi product line came sliced into this evolution. Around 2005, 2004, we come with a separation of control and data plane. We realized that that has to be done. Especially in the wireless, we have to manage thousands of end devices, network elements. You have to separate the control and the data plane and move the control plane out of the AP or partially out of the AP into the centralized place in order to be able to understand the whole network as a whole. Implementing the policy, which means programmable data plane or the edge. A question was where these policies applied on the wire and the wireless. It's applied in the same way on the AP as on the wireless. More important than the AP on the wireless side, it has to be movable or mobile. So policy cannot be static. It has to be tracking the session and transfer from one AP to the other AP, which is a function of the centralized controller, or can be also localized in some cases. And second, and the last one, which is not really timeline 2010, maybe it's earlier, is virtualization or splicing of the network. Ability to provide multiple services on the same wireless network and isolated one from each other. And we know well in the wireless that splicing using the new SSID is not a good way to go. You cannot scale. The IdentiFi architecture is built and on the 4D architecture principles, is inspired basically on 4D architecture, evolved independently of 4D architecture, but basically consists of 4 elements. Consists from going from the bottom of the data plane, which is distributed data plane both on AP and on an appliance. There is a dissemination or control channel between the AP and the IdentiFi appliance, which is used to provide, besides configuration, also control. And it's a key point that dissemination has to control the edge, has to control the access points, has to provide programmability and push the programmability of the flows down to the APs.
When you say appliance, what do you mean?
Appliance means is a central decision maker. Today we call it appliance, or it can progress tomorrow to be the SDN controller or part of the SDN controller. But today this is our appliance that we sell either as a hardware appliance or as a virtual appliance. Coming back to the previous slides, that was introduced 2004-2005. So this is centrally instantiated.
Sounds like a controller.
Yeah, we use the marketing term around the IdentiFi appliance. A couple of reasons, but now specifically around SDN, because SDN controllers and people get confused, even our own internal conversations, engineering conversations. So it's a marketing term. You can call it a wireless controller that you know traditionally. Certainly for the sake of this conversation, hopefully it's a little bit easier to interpret the IdentiFi appliance separate from an SDN controller.
Until SDN show up from 2009, was coined as a term, and a little later it becomes more prevalent, it was easy to talk about the wireless controller. Now it's more difficult because it's very easy to confuse them, one with each other. Because this appliance is not the one which is providing the programmability on normal interfaces. It's providing all these 4 elements, and most important element is decision, or network-wide decision. And the network-wide decision means that it can sense, meter events and metrics from the edge, combine them with internal logic or external engines logic, like from the Open Fabric server, to come with the decision what should be done for the particular user with its flows, traffic engineering, with security, access control, or with the location, or with the security threats.
The classic definition of a control plane.
Yes. However, this is across the whole network. Scalability, let's just give example, this IdentiFi appliance today in the biggest instance for us today can be 16,000 users or 2,000 APs.
And that's virtualized as well as
yes.
Physical appliance?
Yes. It can be virtualized or virtualized means that it's not just virtual machine, it actually can live in the public cloud.
So each one of these devices are building a control right to your controller?
Exactly, yes. So they do dissemination channel. They discover the appliance. There are different methods of discovering it. They can discover it locally, if it's locally deployed, or you can discover it in the cloud, if it's a cloud deployed. Build a channel, which is secure channel, IPsec channel, which is capable of going through the firewalls, having proprietary fragmentation to be able to go through the firewall, MTU adjustment, typical path MTU discovery, to be able to push not only configuration, but control through this channel. And when it cases of the, I'll come later to that, but just to mention that usually this appliance go in pair. As a central decision maker, you have to have a solution for the reliability. So they build actually 2 tunnels to the 2 of the controllers. Discovery, what does it mean discovery in this context, and how we say discovery? Discovery is a local, it's a self-forming cluster of APIs, because some of the functionality we decided are not going to be done by the centralized controller. And they can be done better, more efficiently on the local place.
Are you thinking like RF, auto channel, those kind of things?
Yes. Sorry, just coming back to this slide. So what is on top of this black box? This is actually what Marcus was talking about. These are all additional services that now can build on top of this abstraction layer. So key is here is point of abstraction. It's not about OpenFlow, it's not about technology, it's about where you abstract your network. If you properly abstract your network, then you can give proper scaling and innovation. And this is the point of abstraction on the wireless network. On top of it are the services which feed from that abstraction to give their own view on the network, which separate from IdentiFi appliance point of the view, which is basically roaming, key transmission, RF. On the the northbound is user, MAC, IP, authentication status, and so on. What's the advantage of this architecture? Why we think that this is a good architecture? Because operate on the entire view of the network and can deliver network-wide objectives. So coming in the point of view of configuration, if we just talk about the configuration, is that the mantra is not configuring an AP. We don't configure the AP, we configure the wireless edge. We don't control AP, we control the service. Because for client or the customer, it's not about this AP or that AP, it's about the service, the double and service, the SSID. And it doesn't live on one AP, it lives across the whole domain where the service is deployed. Advantage is because it can directly observe the network. It can sense the status of the client, authentication status, can sense the location, can combine and compose that events together with other decision-making engines. It's a balanced approach. We decided not to do everything centrally. There are things that we use locally, and I will name it. Auto-channel selection, it's auto power adjustment, it is channel load balancing, and it is band steering. At least 4 of them, which we do locally by having cluster of AP, which talk with each other over the wired network and coordinate their function to support Y, because it's not network-wide function. It can be localized. And very important, but it does look like that, but it's very important is independent evolution of infrastructure and service. What does it mean? That you don't really, you have a sliced network. Each service looks at a network as its own domain, isolated from each other. You don't have to replace the network in order to provide new services. And adding new services on the network is orthogonal of the physical infrastructure.
So what coordinates things like when you talk about, a cluster of APs that handle, channel planning and roaming and things along those lines? What coordinates, hey, these 30 APs are talking to each other versus, hey, all of these 500 APs that are within an RF earshot of each other?
So basically, you define a group of APs.
So it's a manual definition from the IdentiFi appliance.
Control. So you put the AP into the
into a self-created group.
Yes. And you say, and then they establish itself, they establish a cluster, and they change information between them using that cluster to know about whatever they need to make their own decision. Yes.
And what's the maximum number of devices that can live in a cluster? I'm thinking about like stadiums where you have, 500 APs that are all within RF earshot of each other, right? Are you letting all 500 of those APs just coordinate amongst themselves and say, go have fun?
No, on a stadium not. It depends on the deployment.
And we don't need that many APs.
Yeah.
So which are the services provided by the controller?
Want to disclose all of the magic that we do in those stadiums.
What services are provided by the controller, by the appliance? We call something virtual network segments, which is actually slicing of the network, and it's a combination of the double and original SSID, policy, and the topology. Is bridge AP, bridge controller, VLAN, and so on. This define one slice of the network, and you have many of them parallel over the same SSID, actually. That's very important for the wireless because providing independence of the services from each other by slicing a network should not be done by instantiating new SSID. Making new SSID is new beacon on air, new Nikon on air is an additional 10, 20 milliseconds of airtime. You do this on the back of the network through the policy and through the topology by providing the same SSID and ability to identify who is actually the user coming on that SSID. Flexible topology and traffic engineering, that's a policy for us. That means that from central place, from one fabric, the decision, very rich set of rules on very different parameters, decide what will happen, how this traffic will be treated for that particular user. It's applied on the wire, it's applied on the wireless, and the responsibility of the wireless appliance is actually to track the session and pass that information from one AP to the other as the guy is roaming or the client is roaming. One of the appliances, of the services that are proxy. Eliminate, there is no need of broadcasting of ARP request in the wireless network when you have a centralized decision maker who knows all the mapping from the MAC to the IPs. All the ARP requests are proxied by the controller. My mobility management, in mostly what I think here is key management and transfer of the context of the session as it moves from client to client. Includes the keys, includes the policy set, includes other attributes of the session as the session is moving around into the network. And that can move between thousands of APs.
And how long does the controller hang on to proxying that ARP request? Specifically, when you're talking about roaming from manufacturer extreme to manufacturer somebody else, right? When you do that roam in other folks' solution where you've got a controller that's doing proxy ARPing, that controller retains that proxy ARP entry for a significant period of time, causing roaming out to the other vendor's solution to be basically broken.
So it's done basically but by sensing that actually that MAC address appears on the wired interface. Especially if you roam, you have to do layer 2 cleaning up the ports. Even inside our solution, when you roam between one AP with other AP, you have to inform all the switches behind that something happened, that they will not return to that MAC address in their own table. So he's sensing the network from the wired side, and if you see that that MAC address is actually coming from the wired side now, it will clean the entry for that ARP instantly. Yes.
Well, I'm curious, realistically, I mean, how is that even possible? I mean, I don't know of any networks that you're going to roam between two different networks and still, because you have to do a layer 3 roam.
Networks. No, in transition networks, absolutely. If you've got vendor A and vendor B, and you're going in doing a rip and or not a rip and replace, if you have to do a gradual migration, and you end up with a hospital where you've got floors 1 through 4 are vendor A and floors 5 through 6 are vendor B, especially roaming floor to floor.
You have other issues as well.
I mean, there's more than that. I mean,
that gets very complex.
But it's a good question. I think it's
I mean, we actually
question.
had that exact scenario, so it's not actually that outlandish in a healthcare.
Yeah, absolutely.
In a healthcare account, and
especially for voice networks where you're doing PSK, you're not doing .1x auth, right? Where you're.
I don't know. I hope it wasn't your. No, I'm just, no, actually, I won't name the vendor. I mean, respectable vendor. We did some magic on our side and actually made it work, and it was a transition time where they were actually using both Wi-Fi systems. They were using ours to replace what was there, but it was actually a voice deployment using, I believe, Vocera system through the ER, and it was pretty painful, but we actually worked some magic on our engineering side to make it work, surprisingly.
Not to stray too far, but isn't like Wi-Fi offload of mobile networks going to be
CWG.
successful when it really it's going to be in the middle too, right?
Yeah.
So if we want to go in detail, I just say how our proxy works is basically it has entry maps MAC address to IP address, easily to find out when some associate to the network. We right away find what's the MAC address coming into the network. On the wireless side, we associate IP address with either DHCP request or through the passing of the traffic. We have that binding. That binding is key how long you hang on to that binding. And you hang out until the session times out, or you sense that that MAC address appears now on the wired network. If neither of this happens, you have to hang up until the timeout of the entry. And it's most of the cases it will work. There are some cases probably that will not show up as a MAC address on the wired network, and something special has to be done to handle that one.
You had mentioned earlier that your policies are applied locally. When we were doing the very first presentation, that the app level policies. And here you say that your WIPs and prevention is handled by the appliance. So that's kind of a part of that, but for throughput tracking or tracking applications, is that done at the appliance or inside the AP?
Okay. So intrusion detection is a very good example because it's shared between the AP and the controller. So AP collects and does deep packet inspection to identify the threats. The database is pushed from the appliance to the AP, and AP locally does that detection. When it detects, turns that into events and passes through the control channel to the centralized engine. The central engines correlate now with other APs. Did I see this event somewhere else when I saw it last time? Is it this possible rogue AP? And instruct the APs to take action, attack, detect, but it's important that he has to correlate, someone has to correlate with other information, but AP part does part of it, which is basically deep packet inspection, which is not done on the appliance, is done on the AP. It does collection of all, does background scanning, collect all the beacons, pegs them, provide information, send as events back to the centralized engine, which does correlation across the network.
So you don't end up with 30 reports of one attack.
Yeah, sure. All reporting comes from the centralized engine, not coming from the AP. Just provide information in order to come from the centralized engine. Location engine, APs collect RSS, average them, do whatever it takes to need to avoid fluctuation with the plus minus dBm of the standard deviation, and then send that that reports back to the centralized location engine running on the appliance, which triangulates and finds the location for every possible session on the appliance.
Now, do you actually access that data on the appliance, or do you have to feed that up to another platform in order to plot dot on the map?
Appliance.
Okay, so then where do you draw the line between dot on a map, looking at the appliance, and things like location analytics,
So
trending,
it's
dwell time?
the appliance.
So it's
northbound.
another appliance.
Yes, which is basically like one fabric or third-party system which can get this information from the appliance and get information. So let's query the Mac user and say, give me what's your location. Plus, he has to have a map which we provide to. And this is the last, actually the most important, resilience and survivability, is any solution where you have centralized logic maker, you have to have a solution to provide for the outage. What if appliance is not there? Our solution is 90% of our sales is paired appliances. We provide the fully failover solution where we partition the sessions, and each of the two appliances runs the consistency protocol to synchronize between them. So if one goes out of service, the other one takes over with full context switch, no information loss. And this is a key to provide scalability to the 16,000 users, 2,000 APs, and going further in the next releases that we are coming. So this is what is architecture, what we believe our advantages are, and this is one example what we do on this architecture. And one example is the policy. Policy is the SDN application running on this architecture. This is something which is running today. It's running from 2008, and it's same policy and granularity and action between wire and wireless. Where it's enforced on the AP, not on the switchboard. It's a fine-grained control of application traffic. It implements match and action paradigm, same as OpenFlow, but this predates the OpenFlow. This was before the OpenFlow. Matches based on the layer 2, layer 3, layer 4 parameters. It provides actions. Actions can be access control, allowed deny, can be QS, prioritize this flow, mark the flow, or rate limit the flow. Rate limit upbound, rate limit southbound. On which topology this flow will be forwarded. It can be forwarded locally, or it can be forwarded centrally through the data plane on the controller for the overlay solution. These are defined per policy. It's defined per user. So even the same SSID, you can have two users having completely two different policies. It's one SSID, but they completely differently treat users completely treat differently. They end up with completely different VLANs, their traffic, for example. Or one is allowed to access it, and one is not allowed. In order to make decision, policy has to be fed by some events, and that events, we constantly grow them, and Marcus spent some time explaining, but from the wireless, specifically, we provide events toward the one fabric to be able to execute the rule engine. And what we're looking at the client identity. Who is the user? What's the authentication status? Is it authenticated, not authenticated? What's the location? What's the application that it's running? All this is fed into the centralized rule maker, and that policy which is derived is pushed back to the controller. Controller responsibility or appliance is to track the session and to apply that policy where that session exists. So for example, it's in the API, then through the control channel, that policy and the flows are programmed onto the AP and applied. So basically computing the flows or preparing the flow of the flow table, and determining where that session is currently active. We allow flexible traffic engineering. We have two domains of forwarding. In one policy, all flows can be forwarded in the bridged AP. What does it mean? As the traffic is coming to the AP, after it matches the rule, whatever it matches is going to be locally bridged on the network coming from the AP. It can be on one VLAN or multiple VLAN, doesn't matter. Or it can be encapsulated in the control traffic, in the control channel, passed all the way to the controller and bridged centrally. So you have user who is locally bridged, and you have user who is centrally bridged, because you want the traffic to be inspected maybe somehow else differently in the central location, or because that's how you want to deploy your network.
Can you have split of that inside one single user based on other attributes?
Yes, actually the split can be very simple. You can say HTTP traffic is all centralized, go to the VLAN 100 on the controller, everything is bridged AP locally. So the HTTP traffic will go up, will come down, and everything else will be locally bridged.
How do you solve the split IP problem? Are you doing some form of NAT at the controller to say, well, if it goes centrally to the controller, I'm NATing it to this address space?
We do something.
That's the best answer.
Which allow the ARP to follow the same flow. And coming now to examples, okay, this is how policy works. This is decided by the central decision maker, correlated and by rule management from one fabric, really taking events from the network or from the third-party engines like Microsoft MS Link or so on. What example of this one? This is one of the usage of the policy. This is not only usage, but it's one of the usage, very, very descriptive usage, where you can. The problem is the multicast. The multicast is the issue in the wireless, when it comes to wireless, low data rate. You can turn him in the unicast packet, doesn't work always well. So you want to limit your wireless multicast traffic. You can apply the rules which will deny the multicast traffic, and you can get rid of the problem, but not always possible. Especially not possible if we have Bonjour devices which need that protocol, multicast protocol, to find and discover each other. The solution that we are doing with the policy is basically putting all of the multicast traffic coming from Bonjour on a separate VLAN. We separate that VLAN from the VLAN which is unicast traffic is coming. The Apple TV will, the client or Apple TV pulse the multicast on that VLAN, and policy will take, classify, match that particular multicast traffic and put in a separate VLAN and other traffic on that policy for that user. That's how they're going to discover each other. After they're discovered, then they can use the unicast traffic, which is going through the probably router, because it's going through a different subnet. That's way how we isolated the multicast traffic for the unicast, and we're able to pass only the multicast traffic that we want to be in the network, not all multicast traffic. That can be combined with location. Going further, there is two rooms, room 101 and room 202. In the room area 1 and area 2, there is two different Apple devices, and classroom A1 has to have access to device in room 1, but not in the room 2. When the client roams or comes into the room 2, he has to have access to the room 2 device, but not to the room 1. So this is done through the policy, and identification of a user, either association to the AP or based on the regulation, which fits into the policy rule.
So, for example, today, Apple devices don't support opportunistic key caching, right? So if you're using an 802.1x network, you have the pairwise master key, and it has to regenerate a new key every time it goes from AP to AP. Does SDN solve that problem in any way where you have devices that can't do that advanced roaming?
My personal opinion is no, SDN cannot solve that problem, because it's not a level of abstraction where SDN works. So SDN can, probably someone can try it, but the level of that abstraction is too low for SDN to provide some appropriate solution. And solution for that one is to implement 11R, because all of these clients support 11R. And or use the 802.1x radio server, which has the session continuity, which actually cuts the 802.1x process from 15, 20 packets to maybe just 4 packets. So there are other levels where you can solve that problem, but I don't believe it's on SDN level will be solved on that normal interface. should be solved on the different level. Network harmony, or basically more appropriately saying traffic engineering. So we have a user here and who has two devices. One device is corporate, another device is private device. They have to be treated differently, and different traffic differently has to be treated for two of them. The one of the device, which is the private device, should be on the guest portal and should go through the guest portal. Is bridged AP. Obviously, it doesn't go through the centralized path. It goes through the switch locally, and will hit the captive portal. The other device from the same user will go for a central overlay network toward the 802.1 accelerated data center to get the corporate data. This is static. What happens if the third system, like Palo Alto, decides that this client no longer meets the criteria of the policy of the establishment? So you change the policy and you prohibit that client accessing. You change the policy. You change what it can do. Either deny everything or just put him into some walled garden where he can be quarantined for some time. This is dynamically done. And policy push to the appliance is after that propagated to the APs where the particular user is. This is just an example showing that other devices can have a multicast traffic going based locally to each other. Okay, so this is the presentation.
I have a question. We'll go back one slide. My assumption is, and I could be wrong, so tell me if I'm wrong, that extreme APs, to have all these features, require a wired extreme network. Doesn't look like there's much here that can be ride on top of someone else's wired infrastructure.
Actually, it can, right. It's third party, it's switch agnostic, can be switch agnostic. What it needs the one fabric, it's a one IdentiFi controller and our AP. And it can run all this, not wireless, because for wired part, of course, you cannot, but at least the wireless part, all this functionality can be implemented without intermediate.
So all you need to add is your appliance and APs.
APs, yes.
Yeah.
And the one fabric.
Actually, I don't know of a single feature that would be dependent on the wired switch behind. It's all an overlay model, so to speak. When we talk about converged wired wireless, our view of the world is that you might have a client that is sometimes wired and sometimes wireless, so you want to make sure that you can manage that appropriately and seamlessly, but it's not a serialization where the AP needs to plug into a switch that provides.
And why this is possible? Because of this concept, dissemination. We communicate with the decision maker through the secure channel, through the control channel. It doesn't matter what's below. Is it Enterprise switch or Cisco switch? Doesn't matter. We establish the channel, and all information, this all information can traverse the internet. It doesn't have to be local. So we don't depend on the distribution system. Exactly because of the architecture.
I was wrong.
Yeah, and we can use those services and obviously on the wired infrastructure as well if you want to, but that's another option, obviously.
Any other questions?
In terms of moving forward, we talked a little bit about SDN. What do you today? You guys use an overlay with IPsec to the controller. Do you guys see that overlay changing in an SDN world? Do you see more of a standards-based, like VXLAN or NVGRE?
So here we come. I will answer. Maybe Marcus can answer also in the same time. But okay, maybe Marcus go forward, and I think this picture is the one which will answer the.
Yeah, what you mentioned in terms of transport, actually, you mix data and control plane. So as we talk about IPsec and that wrapper into IPsec, it's only control plane traffic that is wrapped into an IPsec net tunnel, so to speak. From a data plane perspective, we are open from an architectural perspective. We can also use IPsec back to the controller, but that's only one option. So the preferred option today is really to break out locally at the AP into the next switch using traditional VLANs and one queue. So there's no need for that. And we do have in mind that we, as part of the policy assignment, that we do support moving forward different modes than IPsec or just bridging into a VLAN, which would include GRE, VXLAN and a few others. So that's under consideration, and it would be for us just a different policy that we would drive.
Yeah, basically the control channel that we have today, we're not going to replace with just other implementation of existing, but we will expand on that.
It's more data plane options, so to speak.
So instead of just saying ride the control channel back to the controller or the appliance, you're saying we may have other options in terms of like a data overlay.
Yeah, exactly.
exactly,
Different data
exactly.
plane options. Yeah, exactly. Yeah.